Hello everyone, and welcome to my Unreal Engine tutorial on adding custom flags to the character movement component. I've seen that in other tutorials they show how to do network movement in Unreal in the character movement component, but they only use the default flags, which since there's only 4, you run out of them pretty quickly, and there's a way you can get around that. So this will be using the default third-person template, C++, since this will require C++, and let's get into it. So first, what we want to do is create a new movement component. So let's do that real quick. And I'll just call it multiplayer character movement and create that. And now once that is created, we can move over to C++. And first we want to add the public descriptor here and move over to our character real quick so we can switch the default movement component out for our new movement component. So move over to the .h file and add this to your constructor, const class f object initializer. Make it a reference and just call it object initializer, and to create that, and then add this to the constructor in the CPP class. Do super object initializer dot set default subobject class. And then since this is a template, we want to move our arrow over and add this to that and specify your new movement component. So for us, that's multiplayer character movement component. You will probably have to include that if you're using Visual Studio, but since I'm using Writer, it does that automatically. And then once we add that to the template, we have to do a character, since that's where we're inheriting from, and character movement component name. And once that's done, you should be able to compile in Unreal and see your new movement component. We'll see if that's all good, and we'll move on from that. And once it has finished compiling, we should be able to see our new movement component in the third-person character. Technically in Unreal Engine 5, we don't actually have to do the stuff we did in the constructor. Could have actually just selected it here, but this is the way we did in UE4, and I'll just do it the same way. Okay, so first, once that's done, we want to go back to our character movement class, and right above the public descriptor, we want to create a class for the new network move data that we're going to be replacing the default network move data with. So f multiplayer network move data, public f character network move data. And we want to specify public since this is a class and it doesn't default to public. And we want to do a type definition of the superclass, which is f character network move data super. Technically we don't actually have to do this, but it just makes things easier. And next thing we want to do is override two functions from this class, which will be virtual void client network fill move data, which will be filling the move data, and virtual will serialize, which is where we'll be I guess deserializing and serializing the data, or reading the data and writing the data that we're sending to the server or receiving from the server. And here, and the last thing we want to do is create a UN8 and do custom or move data custom movement flags. And these are the custom movement flags that we will be using, since we're not going to be using the default character movement flags. So once that's done, we can move on, and the next thing we want to do is create a new move data container, which will also be replacing the default move data container. So class multiplayer network move data container, public f character network move data container. And we want to again add the public specifier and add the constructor for this, which is where we'll actually be saying that we want to use this move data container instead of the default. And we want to add our network move data to this, since this is the container for it. So f multiplayer network move data custom default move data, and we need to add it 3, or make it an array of 3, because in Unreal they have the moves, I'm pretty sure, as old, pending, and new, or something like that. There's 3 moves all at the same time, basically, and they will be contained within that. Yeah, new move, pending move, old move. Those are all the moves. That's why there's 3. And the next thing we want to do is create a class for our saved move. So f multiplayer saved move, public f saved move character, and do public descriptor. And we want to again define our super class. We don't actually have to do this if you don't want to, but it just makes things easier. And we then want to override 3 functions, we can do 5 in this save move class. So we want to override void clear, virtual UE5 get compressed flags. This won't actually really be used because these are only for when you're using the default flags, and since we're using our own flags, you don't actually need this, but I'll just keep it here just in case. Then virtual bool can combine with, and then I'll explain what all of these do. Virtual void set move 4 and virtual void prep move 4. And basically we can basically clear resets all the saved variables, so we want to type that. And get compressed flags stores input commands in the compressed flags. So can combine with, it basically just checks if moves can be combined together. It can, I guess, save bandwidth in a sense. If two variables are the same in a move, then instead of each sending 2 separate moves, we can combine them, and that just saves bandwidth. So set move 4 sets up the move before sending it to the server. And prep move sets the variables on the character movement component before making a correction. And once we have that, we want to add one more variable, which will be UN8 saved, what did we call it again? Saved custom movement flags, which will be the saved version of the flags that we will be using. And last thing we want to do is create one more class called the network prediction data. So f multiplayer network prediction data client, f network prediction data client, character, and add the public specifier. And next thing we want to do is add the default constructor, which will be f multiplayer network prediction data client, and we need to specify the character movement component, which will be right client movement. Next, we want to define our super. Again, technically don't have to do this, but makes things easier. Wait, oh. And last, we want to override one function called allocate move. So f saved move pointer, allocate new move, and basically this just creates a copy of our new saved move. Okay, and now once we're that, we want to make a friend class of the f multiplayer saved move, and now add the default constructor for our multiplayer character movement component and our move data container. So f multiplayer move data container. And now we can define this. And this is where we're actually going to set the new movement data container. So set network move data container and set it to our, or we should probably just call it custom move data container. One sec. And now we have that done. And then what we have to do next is we have to override, or next thing we want to do is create our new flags, which will be represented by an enum. So call them e custom movement flags. And then just do c flag. C flag. And then since I'm going to be showing off how to do sprint with this, I'm just going to call our first flag sprint. And next you want to do a binary left shift. And then we want to, this will be our actual flags variable, which will be in UN8. And because the enums are just integers represented with like names, we can just have this as an integer and call this custom movement flags equals 0. And we want to now add, oh, we don't need that. We want to now add 3 functions called virtual void activate move custom movement flag, and add our new flag. So e multiplayer, oh wait, e custom movement flags flag virtual void clear movement flag e custom movement flags flag. And our last one will be is custom flag set flag, and we can make this const since this is only a getter, and we can actually do this on the spot since again this is only a getter. And return, do parentheses flag, or here do custom movement flags and do flag. And then if this is not equal to 0, then it is set to this, to whatever flag we specified. And next thing we want to do is create a definition for these. So do that real quick. And once we do that, we can do custom movement flags. This writes the flag to the integer. So flag, and this is how we'll clear the movement flag. Custom movement flags. Do that flag, and now we have that set up. And we can move on to our next thing, which will be overriding some more functions from the default character movement class. So we will need to, and now that we can move on, we will have to override some more functions from the character movement component. Some of these won't actually be used, but they're just useful to have just in case you end up using the default flags. So they will be virtual update from compress flags. This won't actually be used unless you're using the default flags in the engine. And then virtual class f network prediction data client, and we'll override the get prediction data client. We then want to override virtual void move autonomous, which will run on the local client. And actually that's it. So now we can just call this. This doesn't actually need any definition. We can just keep super here, unless you're using the default movement flags. We won't cover that in this tutorial though. Next thing we want to do is override get prediction data client. And here we need to do a check if the pawn owner is not null. So basically check if they're valid. If they aren't valid, then this will crash. So if, and then we want to check if the client prediction data hasn't been set yet, and if it hasn't, return client prediction data. If it hasn't been set yet, then we can set it ourselves. So get a pointer to the character movement component. So this will be mutable this equals const cast. Since I'm pretty sure this, since what we're getting from is technically cons, then we can, it allows us to override the variables within the character movement component in a sense. So once we do that, we can do u multiplayer character movement and make sure the template parameter has a pointer, and do this. Then go from mutable this, and set client prediction data equals new f this. Oh wait, no. God dang. F I cannot type. Jesus Christ. F multiplayer network prediction data client. And then dereference this pointer. So do this. So this will create a new multiplayer prediction data, and we're going to set it in the character movement component. And then from that, we need to get mutable this and set the client prediction data max smooth net update distance equals 92.f, since this is a float. I'm pretty sure these values came from Unreal Tournament, so I mean, you're free to change them, but here, mutable this prediction data, no smooth update distance equals 140.f. And once we are done that, we can go back to our character movement component and go to move autonomous. And once that is happening, once that is finished, we can get a pointer to our move data. So go to f multiplayer say network move data and call that move data equals static cast f multiplayer network move data, and then get current network move data. Oh, what the? Get current network move data. Let me just, okay. What's wrong here? Oh, forgot to add a pointer. And then next thing we want to do is just check if move data is still valid, so not equal to null. If this is not equal to null, then we want to set our multiplayer. Oh wait, what did we call it? Oh, custom movement flags. Custom movement flags equals move data custom movement flags, and this will just set it from the move data. And we actually want to move this call to the superclass below this instead of above. Pretty sure it's just due to timing, since you want this to happen before anything that happens here. And next thing we want to do, we can pretty sure okay, so we can move all the way back to our F network move data, since we're gonna have to start defining these functions. So generate definition for client fill network move data, and also serialize. And then the next thing we have to do is go here, and we can actually switch this out for super, which is where that comes in, and get a const reference to our save move. So F multiplayer save move equals static cast const F multiplayer save move, and get client move right here. And once that's done, we can set our move data from the save move. So get here, right here. And once that's done, we will set our move data custom flags from the saved data. And we can now move on to our serialize function, which will have the super coming from it. So get that. And this will be a useful variable for when you're serializing your data. Technically, the serialize function can be used for sending other custom data. It's not just flags, though that has issues with allowing the client to modify the data since it's coming from the client. So const is saving AR that is saving, and do serialize optional value. And since this is a template, we have to define the type, and since these are flags, we're going to use uint8. B is saving AR move data custom flags, and we will set the default value to 0. And once that is done, we can go back to our .h file and go to our multiplayer move data container and define our constructor right here. And here we want to set our new move data is equal to our custom default move data, and get the 0 index, since this is the new data, and we're going to do the same thing but incrementing it each time to the pending move data and the old move data. So do pending move data equals custom default move data, and get the first index. And for the last one, we can do old move data equals custom default move data, and get the second index. Now that is done, we can move on to our clear function in the save move class. So generate the definition. Should be able to just call super instead, And here we want to, this is where it will clear any saved move data. So we want to set our saved custom flags is equal to 0, so there's no more flags set in a sense. So once that is done, let's go. Oh wait, I forgot to. Okay, so go back to your serialize function, and we have to return something here. So this AR dot is error. This is basically telling us if the serialization was a success. So basically, if it's not an error, then we will return true. If it is an error, we will return false. So once that is done, we can move on to our get compressed flags function, which really doesn't actually need to exist, but here do UN8 result, which will be this will only be used if you're using the default flags in Unreal. So UN8 result equals super get compressed flags, and then we want to return our result. And the next thing we want to do is move on to our can combine with function. So let's define that. And here we want to, this will require a little more setup. So first we want to get a pointer to our save move. So multiplayer save move, new move pointer equals static cast f multiplayer saved move new move dot get. And here we can see if we can combine with so basically we're going to check if the flags are not equal to each other, and if they are not, then we can't combine a move, because if they are equal to each other, then we move on to the next variable. And basically if two moves are the same, then we can then we can combine them. So do if saved custom movement flags is not equal to new move pointer saved custom movement flags. If they are not equal to each other, then return false. Otherwise, we can return our super function and maybe combine the move. So next we can move on to set move 4. Here we can do super. And here we want to get a pointer to our character movement component, which can come from the character pointer right here. So we do u multiplayer character movement component CMC equals cast u multiplayer character movement component c get character movement. You will have to include the character.h here, just in case you haven't. And next we want to check if the CMC is valid. If it is, we want to set our saved move we want to set our current variables to our saved variables. So do CMC custom movement flags equals saved custom movement flags. And next thing, we can move on to prep move for. Super. And we'll do the same thing, so we can just copy and paste this. And again, check if the CMC is valid. And if it is, so go back to this, and this is where we're setting the saved. I made a mistake. So this is where we're setting the saved to the CMC's variables. So this is where we're saving the variables, and this is due to a correction. We have to reset to what we saved. So here we do CMC custom movement flags equals saved custom movement flags, and that we'll then get the saved variables and set our current variables to our saved ones, just in case there's a correction. And next thing we will have to do is move to our network prediction data on the client. So generate a definition here. Pretty sure you won't actually, so you don't actually need to define anything within these brackets, so you can kind of just delete them here. And then we want to put a semicolon, super, and client movement. And we want to do the allocate new move function. And here we want to return a f saved move pointer is equal to new f. Wait. God damn. Okay. F multiplayer saved move, and we have to add the constructor to that, and we can just save it there. And once that is done, that should be it for setting up everything for custom movement flags, and you should be able to do your own movement stuff. So we can test that here with a sprint. So here, we first need to overwrite virtual float get max speed, and then do sprinting function blueprint callable category equals multiplayer movement. We should sprint, and here we can define that. Oh. Okay, I'm just gonna copy and paste this. So then move to your CPP class and scroll to the bottom and add that. And basically, if B should sprint is valid, or actually, instead, we can actually do this. So if B should sprint is true, so just use the question mark operator. If that is true, then we can do activate custom movement flag, E custom movement flags, and C flag sprint. So basically, if we should sprint, then we're activating this custom movement flag. Otherwise, we will clear this movement flag. So E custom movement flags, C flag sprint. And last thing we will have to do before testing is defining our get max speed. So basically, unless we have the sprinting flag in our flags, we want to return the super, so keep that there. But if we do have the sprinting flag, so is custom flag set is multiplayer. Oh wait, what did we call it again? Oh yeah, E custom movement flags, C flag sprint. So basically, if the C flag sprint flag is set, then we will return our sprinting speed. So we can create a variable here, property, edit anywhere, category, and just set the category to sprinting as a subcategory of multiplayer movement, and set this to blueprint read write as a float, and do sprint speed, and we can set this as a default to like 1200. And now go back to your character movement component and do return sprint speed if we have the sprint flag set. And now everything should work, so we can compile in the editor and let's test it. So just compile. And now, once that is all compiled, it should succeed. If it doesn't, then something might be wrong, and you should probably go back to a later part or an earlier part in the tutorial and try to see if you can match it up with mine. So basically, we can go to the character movement component. We should see a sprint speed variable right here with a speed. You can change this on the fly, allowing you to make adjustments to the sprint speed without having to recompile in C++. So now that we have all that set up, we can add our sprint button. So go to set project settings, input, action mappings, and call this sprint. Left shift and go to our character and look for sprint, and now get our character movement component. Okay, so we're gonna have to cast this to our multiplayer character movement component. You can make this a pure cast since we know it's going to succeed. And here we can do toggle sprinting flag, and on pressed we want to sprint, and on released we don't want to sprint. So once that's all done, we can test in a multiplayer game, and we should see our character sprinting. Oh wait, my computer cannot run Lumen. Let me just take that off. Okay, so now I can test. Yeah, okay. So here, and our character runs faster as if when we hold left shift. So yeah, that's how we can do custom flags, and with an example of how to do sprinting with those custom flags, this will allow you to get over the restriction of only having 4 default flags in the character movement component, allowing you to now have theoretically infinite amount of flags, or as much as your computer can handle. And yeah, that's about it. Thanks for watching. I hope everything turned out well, and have a good day.